Okay, so if z is equal to e to the power I theta, what is z to the power n plus 1 over z to the power n? Well, let's go through this step by step using, first of all, Euler's equation, and secondly, De Moivre's theorem. I hope I pronounced the guy's name right there. But first of all, we know that this z here, which is equal to e to the power I theta, is, using Euler's equation, is equal to the cosine of theta plus I multiplied by the sine of theta. Now, let's raise everything to the power n. So we have here our z to the power n is equal to e to the power I theta, all raised to the power n, which will be equal to the cosine of theta plus I multiplied by sine of theta, all raised to the power n. But what does De Moivre's theorem say? Well, it says that this z to the power raised to the power n will be equal to, of course, our e to the power I theta raised to the power n, and this here becomes the cosine of n theta plus I sine of n theta. Now, let's do the substitution in our expression here. So our Zn becomes that. So we have cosine of n theta plus I sine of n theta plus, how do we write z to the power n? We can write z to the power n as z to the power minus n, so that our n here becomes negative. So we now have plus cosine of minus n theta plus I sine of minus n theta as well. Now, let's simplify a little further. This doesn't change, so it's cosine of n theta plus I sine of n theta. What is the cosine of a negative angle? It's the cosine of the angle itself. So this becomes plus cosine of n theta. What about the sine of a negative angle? Is equal to minus the sine of the angle. So this plus becomes minus I sine of n theta. Now, what gets added to what? This adds to that to give us a 2 cosine of n theta. This one is negative, positive, and this one is negative, so this cancels out that, so that this is the only thing that is left standing. So therefore, our z to the power n plus 1 over z to the power n becomes just 2 cos of n theta.